This is a quick 10-minute overview of the Natural Capital Laboratory project, which is a joint venture between a number of different parties. There's Amelia and Roger Lees, who are the landowners who own this beautiful site up in the Highlands of Scotland. The University of Cumbria, who are involved from an academic perspective and who are leading the ICN's work on defining principles and guidelines for rewilding. The SARCC project, which is a rewilding charity operating in the UK and internationally, and then ACOM, which is where I work, which is a big kind of design engineering firm with a particular interest in natural capital. So my background is I'm an environmental economist at ACOM and also a trustee of the SARCC project charity. The background for this project specifically is that we do a lot of work with clients who are interested in natural capital, nature-based solutions, rewilding, basically re-looking at land and how they can manage land differently. And we do a lot of work looking at how we can measure, monitor and track the impacts of these kind of projects and how we can start looking at the costs and benefits and integrating that kind of information into finance and investment decisions. One thing we wanted to do with the laboratory was to set up a sort of basically a kind of like experimental site where we could try out new techniques and approaches to try and develop better solutions and ways of measuring and monitoring environmental impacts, and just better ways of helping people to scale up these kinds of solutions. So the site itself is in a really beautiful area of the Highlands in Scotland. It's about 45 minutes from Inverness and perhaps 30 minutes from Loch Ness, but quite a nice sort of rural environment. There's four sort of, it's quite hard to discuss the lab because it's a weird sort of ever-evolving kind of project, but there's broadly sort of four components to it. The first one centers around rewilding the site. So there's an idea that we want to basically take the site, restore the ecosystems that are there, reintroduce species that used to be there that provide important ecological functions, and engage local communities with the environment. We're working with people who are involved in the IUCN's work on nature-based solutions and on rewilding. And what we wanted to be in a practical sense is a sort of an example in a practical setting of what this kind of process can look like, and do a very public update of like how the project's going to allow people to monitor it and see what it looks like in practice. And then alongside the rewilding process, there's sort of this idea of having a laboratory element, which has got three main components. We're really interested in learning, applying new techniques, trying things out, failing, and then trying different things to see what works and what doesn't, and how we can apply them to other case studies. There's a lot of different groups and people who are involved in this and kind of bringing different perspectives and expertise, which is really interesting and quite useful. But yeah, there's three sort of main components to the research. The first is around data collection. So how can we use new and innovative technologies to better collect data? Ideally, we'd like to know everything that happens. One advantage of having a relatively small site is that we can monitor it fairly intensively. So we're looking at how we can use things like drones, rovers, AI, camera traps, thermal imaging to kind of collect as much data as possible about what's happening during the rewilding process on the site. And then the second stream is around capitals accounting. So there's a set of natural capital accounts that are produced each year, and these measure and value the environmental impacts of the projects and what's happening each year, and they're reported and quantified and valued. But we're interested in how we can extend that beyond focusing purely on the environment to looking at sort of wider impacts on society and the economy. So we're interested in developing things like intellectual capital accounts, social capital accounts, and basically having this big picture impact of what the site's doing for people, for the environment and for the economy, and updating those each year and trying to develop better ways of capturing some of these values, because we're well aware that some of the techniques we use are based on very outdated studies and kind of, pretty crude. So how we can improve and build on them. And the third stream is around communication. So how can we better take technical information and make it accessible to a wider audience? It's no longer really acceptable, I think, for us to just produce 200-page technical reports and spreadsheets and expect people to engage with them. We need to use things like virtual reality, digital platforms, 3D models to make this sort of content more accessible to people if we want to engage them in it. And then I realized it can be quite sort of difficult to kind of talk about something which just sort of exists in the abstract. So this is a short video of the laboratory site, taken from some of the drones that are flying over the site. There is a site on the site, there's a house on the site which is used as a kind of research base, and so people can stay on the site and do surveys and collect data, etc. You can see broadly from this image there's a kind of mix on one side of woodland, so that's plantation and some old birch woodland, and then a large area of clear fell running down the middle, and then basically an area of peat bog which has been replanted before the site was acquired, and then a river which runs along one of the edges of the site. So quite a nice mix of different habitat types. And this is the 3D image, or the 3D model that we've generated from the drone footage that we're using in some of the sort of like modeling work that we're doing on the site, just to give you an overview of what it looks like. So yeah, that is a very quick background of what the site looks like. In terms of where we are with the research and what we've been doing, so we're just about to start year 3 of the project. To recap quickly on what we did in year 1, which was beginning 1st of April 2019. Number of different baseline surveys trying to understand what is there, what kind of species, habitats, etc. What have we got our hands on? And then we developed this idea of having a baseline natural capital account. So looking at how much carbon that's being sequestered, what condition the asset's in, what species are there, and then taking this into a digital platform to create a kind of like engaging format for natural capital. So taking it outside of a spreadsheet in Excel and making it into a web-based visual platform. Then we started looking into, could we develop a virtual reality experience? We're well aware that a woodland, kind of restoring a kind of Caledonian forest is going to take hundreds of years. And so if we're trying to engage people in this, we want to be able to present them with a way in which they can see what this might look like in the future, rather than just imagining it in their heads. So developing a virtual reality experience of what the site might look like and how it might change over time, depending on how we manage it. We did some initial work into remote sensing, so looking at how basically machine learning and satellite imagery can compare to our ecologists on the ground in terms of analysing habitat extent and condition. They set up some drones to do repeat surveys, so kind of predetermined flight paths that allow them to fly over the same routes each year and start putting together a video of how the site's changing visually. And then to develop a baseline social capital account, so basically developing a structured framework following the natural capital accounting framework, but looking at social capital assets, so relationships with different groups and the condition they're in and the impacts flowing from those relationships. Year 2, which is just pretty much finished at the end of September. We're a little bit delayed by about 6 months because of COVID. It was quite a challenging start, but basically the kind of work streams we've been looking at over the last year have been looking at aquatic ecology, so looking into the river system on the site and moving through the catchment using environmental DNA and comparing that to standard approaches to understand how we could better understand biodiversity change in freshwater environments. We did further work on the visualization and the VR process and worked on a new VR experience with some species reintroduction, so elk and wild boar, and then developing that for the BBC's Country File program about the project. We did some work on remote biodiversity monitoring, so setting up camera traps and audio moths and trying to automate the collection of biodiversity data and the analysis of that. And then we did a kind of deep dive into the peat bog on the site, so putting in dip wells and various Russian coring samples and trying to understand how much peat is on the site and what condition the peatland's in. And then finally developing the sort of updated set of accounts, so we can see how the impacts of the project have changed over the first year and kind of looking at the costs and the benefits of that. So that's very quickly overview of the lab. Year 3, we're just kicking off the 1st of October. There's a number of different areas of work we're looking at. So just to quickly run through it, but I don't want to take up any more time, some discussion. So looking further at the VR work and working with the UK GDC on the virtual pavilion at COP to take it to a wider audience. Continuing to monitor the peatland and developing a peatland restoration plan. Starting to extend the capitals accounting framework to basically better improve the data and extend the coverage across the different capitals. Starting to bring in students and AI approaches to kind of analyze some of the biodiversity data and automate that process where possible. Further explore the use of remote sensing, so looking at how that can be used to monitor changes in carbon, which is obviously a key thing that we're really interested in the site, being a kind of carbon-based, nature-based solution. Looking at the quality of soils and how they're changing, so doing baseline soil survey. Looking into data management, so looking at how we can take data, collate it, coordinate it, and automate data management, and how we can put that into a digital twin. Then looking at the potential for reintroducing species and which species may be brought back to the site to play important ecological functions. And then doing some work with nature metrics to pioneer air-based eDNA approaches where we can monitor what's happening on site in terms of the DNA that's collected in the air. And that's year 3. So I think I'll stop presenting there and hand over back to the Q&A.
Thanks, Chris. That's yeah, it's a really interesting example. Looks like a beautiful site. How much time do you actually get to spend up there?
Well, I think last year was difficult because of COVID, but I tried to get up there every sort of 2 or 3 months or so if I can.
Yeah, it looks beautifully tranquil. I can imagine. Yeah.
Yeah. I'll just add as well. I realise I've just thrown a lot of stuff out there. And there's a lot of kind of things glossed over. There's a lot more detail behind any one of those aspects, and can be quite flexible. If there's any particular areas of interest, we can kind of go into a bit more detail about any of the particular aspects.
So I guess the what we're trying to focus on in this breakout room, is the modelling and measuring of nature-based solutions. The benefits provided by NBS. So I guess my first thought would be, given that broadly speaking, I'd say that terrestrial application of nature-based solutions, working with nature, natural flood management approaches is more mature than at the coast, particularly when we think about applying nature-based solutions in a more urban or heavily modified environment. So what can we learn from terrestrial approaches to modelling and measuring, working with nature? From examples like yours, Chris, what can we learn from those, and how do we translate that learning across to the type of examples that we're looking at in the SARCC project?
I guess the initial thing, I think you've probably all heard about natural capital and have kind of thoughts on it one way or another, but I think I think it's got a lot of kind of like policy traction, particularly in the UK, and I think globally there's sort of growing interest in it. I think what's really useful about it is that it has a sort of quantitative framework for allowing us to measure progress and report on it in a quantitative way, and allowing us to be basically to hold projects to account and what they're actually delivering. I think a lot of the work we used to, well, we still do, but on big projects has been doing a lot of work up front and saying all these sort of things will happen, and then not doing much on the way of monitoring things over time and recording and collecting data. So most of the data collection's gone at the baseline stage and not much afterwards. I think the sort of natural capital accounting framework is a really useful way of kind of collecting and sorting and presenting information to track change over time and to look at the values that are being provided. I think just there's definitely sort of caveats about the accuracy of some of the approaches and the models and the data that's being used. But since I've been working in the sector, which is about 10 years, things have kind of come on leaps and bounds. And I think as long as people are accepting that it's something that evolves by doing, and that you know, the more you do it, the more you learn, the more you invest in it, things improve and you get better, and the whole sort of framework improves. And yeah, I think it's a really useful thing that can be applied to different contexts. I think a couple of caveats as well on actual GAAP accounting is that the sort of the spreadsheet type based approach can be really unengaging to some people, and this idea of reducing the environment down to a number on a spreadsheet just kind of puts people off. So having a sort of like visual component allowing people to see what you're talking about alongside having the numbers which allow you to track impacts over time is quite a useful combination. And then I think I'd also add that it's not enough to just focus on the environmental impacts. There has to be consideration of things like communities, trust, reputation, vulnerability, jobs. All these other issues have to be sort of like captured in a project. Health and safety is another big one, because that's what people care about, and having this sort of like framework, I think, extended to sort of the broad, all of the impacts that are important to a project is really key.
Yeah, absolutely. All really good thoughts, and I think that's right. If you're establishing a set of approved and agreed metrics up front that then allow you to report the progress and the delivery of over time of your project, your scheme, then presumably that helps to secure the upfront funding, because this is sort of something I guess we're sort of we're grappling with, and that other groups within this webinar might be talking about, is thinking about how we establish standards of protection for nature-based solutions. At the coast, there is a long reliance on having fixed defence crest heights that deliver a very quantifiable standard of protection against a certain set of annual return events, and that's the basis for securing your funding, because you demonstrate the standard of protection you're going to provide, and you will then secure your funding against the benefits that you're going to deliver. But with nature-based solutions that might which are based around a sort of a natural system, it might be in a state of flux, it might take many sort of years of management and investment to build up the defence or protection that's provided by that natural system. So I think this is we don't have an answer to that at the moment, but I think how reliably can we hope to establish a form of an equivalent of standard of protection for nature-based solutions at the coast. I guess that's good to hear your thoughts on that, Chris. But anyone else who's in the room, we can use the hand up function. We've got Will. Got a hand up there.
Hi there, Justin. Yeah, it's Will Todd from East Anglia here in the Partnership and Strategic Overview team at the Environment Agency. In answer to that sort of last point you raised, I think that's a really, really important one, because we've certainly struggled to quantify the benefits as part of the DEFRA NFM catchment scale trial. We tried to utilise some hydraulic modelling to try and quantify some of the benefits that some of these NFM measures may have, but there's some real challenges in it. Not only sort of the scale of the modelling and representing that, but also trying to actually get the features represented in the first place. So I think our learning from that is, there's a big challenge in doing that. It costs a lot, which may, even cost more to do the modelling than, to actually install some of these measures in the first instance. So I think, there needs to be, well, I don't think there's certainly not an easy answer, but I think there needs to be a way of accepting or broadly quantifying some of these benefits in a proportionate way to allow work to, to progress if we're wanting to promote it, without having to go to the nth degree to get a finite answer. So yeah, I'll stop talking there. That'll probably provoke some discussion.
Yeah, good thoughts. That sort of, that difficulty of modelling at the landscape scale, and how do you represent the features that you're hoping to create or introduce, without over reliance on really heroic assumptions that that don't have much of a sort of an evidential basis in fact. Okay, Roy Stokes, got your hand up there.
Yeah, hi, thank you.
Hi.
Morning, everyone. That's a great presentation, Chris. Thanks for that. Very interesting. And from a purely selfish point of view, we're working on a water management scheme in the upper part of the River Severn catchment. I just wondered, apologies if I've missed it in your presentation, but are you doing any measurement of overland flows of that piece of land as well, with the various changes that are going on?
So we didn't actually get into the detail of what we're actually measuring. We're not at the moment. So what we've done in the river so far is basically a kind of baseline aquatic ecology survey and a eDNA analysis. There's some measurement of groundwater levels and what's going on in the peatland, but we haven't been monitoring the flows. There's the water environment on the site's kind of, the site's dammed above where we are. So, and there's proposals to kind of increase the dam and change the flows again. So I think what's going to happen in the water environment is quite an interesting thing. And we're going to be, hopefully, I think, working with the hydro company that are involved to try and measure and monitor what happens under different kind of flow regimes that are happening in the river. There's been wider discussions about how we've done the initial baseline natural capital account is basically kind of like taking most of the data from the literature and using the sort of off-the-shelf estimations and models that give you an initial kind of broad brush estimate. What we're trying to do now is pin down and do more specific detailed modelling for the ecosystem services that are of interest. The one that this year that we're focusing on is carbon, because that's the biggest value, and there's a lot of carbon in the peat and there's a lot of carbon in the trees. So we're looking at whether we can use drones and remote sensing and satellite imagery to basically track changes in carbon in a more accurate way and compare it against things like the Woodland Carbon Code, and see how we can track it for cheaper and faster. Water-wise, I think at some point we'd like to do some work on what the peat bog's doing and how that's affecting water, but we haven't got anywhere with that yet.